Hello everyone, welcome to my new video. So today we are going to solve another question using topological sort. So the question says that you can only take this number of courses labeled from 0 to this. You are given an array of prerequisites where prerequisites indicates that you must take course BI first if you want to take course AI. Okay, so the question says that you have to complete this course before taking the first course. So this is my second course and this is my first course. So the question says that you have to complete this second course, then only you can take this first course, otherwise not. And if you are not able to do that, you have to return false. Let's make a graph first. Like before taking 2, we need to take 5. So let's make a graph. I can only take 2 once I complete 5. So it means I have to, like for 2, I first have to complete 5, right? And similarly for 0, 5, I have to complete 5 before getting to 0. So I can only reach to 0 if and only if I complete this 5. Now for 0, 4, I can only reach to 0 if and only if I complete this 4. 1, 4. I can only reach to 1 if and only if I complete this 4. So this is a kind of graph that we are going to get. So can we solve this question? Yeah. So for this one, we are going to use a topological sort, and after doing a topological sort, we get our vertices in a particular order. And if the number of vertices is equal to the size of the total number of courses, then yeah, we can schedule our courses. Otherwise, we have to return false. So let's see how many incoming nodes are there. It's 0. And for 0, it's 0. For 4, it's 2. For 3, it's 1. For 5, it's 2. And for 2, it's 1. So firstly, we'll use Q to store all the nodes that have incoming nodes as 0. Okay, so let's say a container here. Firstly, I took 1 and 0. Because they have 0 number of incoming nodes. So let's take out 1, and for 1 we have 2 children, that is 4 and 3. So I reduce their 1 degree by 1. So currently for 4 it's 2, so I'll reduce it to 1. And for 3 it's 1, now I'll reduce it to 0. Now I have to check for which one the in degree is 0. So this one. So I'll push 3 inside the queue. Similarly, I have to look for 0. Now for 0, the children are 4 and 5. So 4, the in degree is 1, now it's going to be 0. And for 5, in degree is 2, now it's going to be 1. Then I'll push this 4 inside the queue. And yeah, I'm keep on storing these nodes in a vector, that is, as you can see here. So this is 1 and this is 0. Now for 3. So for 3, the children are only 2. So what will it do? It will just, so the incoming nodes at 2 is 1, so it becomes 0. I'll push 2 inside the queue and 3 here in this one. Now for 4, is there any outgoing nodes? Is there any children for 4? No, I simply put 4 here. Similarly for 2, is there any outgoing node? Yes, there is 5. And as of now, we know that for 2, only there is a 5. The incoming nodes at 5 is only 1, so I'll make it 0 and push 5 inside the queue and push this to inside our vector. Now for 5, is there any children for 5? No, I simply push it here. So our order is 1 0 3 4 2 5 3 4 2 5. Now we have to check that the size of this one is equal to number of courses. Yes, it is equal to number of courses, so we'll return true. Let's check the code. I name this function as canFinish, and here I'm creating my vector where I'm going to store all the courses, all the name of the courses, the size of the vector to total number of courses. If it's equal, then we should return true, otherwise we have to return false. And this is our prerequisite is for which course I have to finish to move to the next course. So for that, like, I'm here using map to calculate the in degree and using this unordered map to create an adjacency list. So in the starting, I have given in degree as 0 to all the nodes. Here I am creating adjacency list and adding in degrees to the child, just to know like how many in degrees or how many nodes are coming inside a child. And I have created a queue where I'm storing all those nodes who have in degree as 0. And if the queue is not empty, so I'm storing that first one, like the top of the queue whose in degree is 0, inside the vertex and pushing it to my sorted array in this one. And I'm in the next one I'm traversing adjacency list for that particular vertex and reducing its child's in degree. If the in degree of the child is going to be 0, then I'm pushing it to my source, and then again I'll push it to my sorted or my vector. And in the end, I'm just comparing if that sorted order size that we got is equal to our number of courses. So if it is that, then we'll returning true, else we will return false. That's all guys. Thank you for watching the video.